The Department of Defense, the Defense Industrial Base, and the nation's critical infrastructure all face challenges in supply chain risk management assurance. These diverse challenges span infrastructure, trust, competitiveness, and austerity. Beginning with acquisition, where supply chain foundations are laid, supply chain risk management assurance extends into operations and sustainment. Supply chains are essential to global competitiveness and national security. Consequently, a supply chain risk management assurance framework will be produced, refined, and sustained. In addition, its rollout and maturity of adoption will be measured. To encourage adoption and motivate maturity progress, appropriate public policy measures will be sought. The scope of supply chain spans technology and innovation, economics and competitiveness, national security, and global challenges strategies. Supply chains are consequential, and their assurance is essential. Adoption of the supply chain risk management assurance framework is voluntary, but may require public policy incentives. The scope of this presentation spans industry background in competitiveness, security, and software. Terms of reference for the Supply Chain Risk Management Assurance Framework. Framework foundations. Risk management and calculating supply chain assurance risk. Supply chain advancement. And conclusion. Industry background focuses on the interacting factors of competitiveness, security, and software, and the overall outlook going forward. Recognize that competitiveness is like floodwater, finding or creating its own path. Competitiveness impacts both software and security as it favors offshore outsourcing, and further impacts security as innovation drives towards mobile and bring your own device. Recognize also that software and security are connected at the hip through the elusive attribute of trustworthiness, and together impact competitiveness in a not-so-virtuous cycle. The question today is, where do we stand? The answer, the situation is dire. We are short on competitiveness and innovation. We are long on offshore outsourcing and technical debt. We are short on trustworthiness and cybersecurity. We are uncommitted to fixed-price contracting. We underutilize next-generation software engineering and undervalue the capability maturity model integration. The most bedrock attribute of competitiveness is the sustainability of workers' wages. The ability of U.S. products and services to meet the test of international markets while sustaining or boosting the wages of the workers who produce them. Issues surrounding competitiveness include increasing dependence on software to achieve competitiveness is not being met with increasing domestic workforce capability and capacity. Enterprises in search of value continue to choose offshore outsourcing for skills and cheap labor. Cybersecurity shortfall threatens continued loss of intellectual capital. Government tax policy, misguided regulations, and antitrust litigation offer impediments and uncertainty. The austerity and affordability challenge has the effect of tying our hands just when the starter's gun signals the start of the race. The most essential attributes of security are trustworthiness, protection, and resilience. Security is defined as the condition of being protected against danger or loss. Software assurance is the level of confidence that software is free from vulnerabilities. It involves trustworthiness and no exploitable vulnerability, justifiable confidence in predictable execution, and conformance through planned and systematic multidisciplinary activities. Simply put, the goal of cybersecurity is to assure the trustworthiness, security, and resiliency of software components, systems, and systems of all kinds, including those used in national defense and the nation's critical infrastructure. Resiliency is the ability to anticipate, avoid, withstand, mitigate, and recover from the effects of adversity, whether natural or man-made, under all circumstances of use. Issues surrounding security include cybersecurity foundations are lacking. Cybersecurity practice is ad hoc, not well understood, and ineffective. Cybersecurity training and certification programs do not yield the capability to secure large-scale software-intensive systems. Research programs are misdirected and promise, but they cannot deliver. STEM initiatives cannot deliver results needed. Executives and senior managers are disconnected from the realities they face. Privacy, civil liberties, information sharing, liability concerns represent increasing resistance and barriers to achieving cybersecurity. The most valued attribute of software is trustworthiness. A trustworthy software system is engineered to rigorously demonstrate completeness, correctness, style, rules of construction, and multiple views in order to satisfy the attributes of trustworthiness, security, and resiliency. Issues surrounding trustworthiness include immature profession continues to stumble in delivering trustworthy software components, systems, and system of systems. Delivered software continues to contain weaknesses and vulnerabilities seeded by our best and brightest that can be exploited. Growing dependence in the nation's critical infrastructure and defense industrial base seek to assure trustworthiness. Next-generation strategies and tactics do not build on earlier work, lessons learned, and achievements from the past. Academia is not connected to the needs of entry-level practitioners. Software engineering continues to be stigmatized. Corporations seek to commoditize software engineering and programming by resorting to outsourcing. Technical debt is growing non-linearly. In assessing the current state of progress, the following observations are offered. Lack of improvement in software trustworthiness may restrain security, but not competitiveness, due to a shortfall in trustworthiness practice and a shortfall in cybersecurity foundations and practice. Limited improvement in educating and fielding the domestic workforce on software may restrain security as STEM promise exceeds delivery, but not competitiveness, as this weakness may serve to stimulate offshore outsourcing. Limited software research and development may restrain security with corporate decrease in R&D spending, DoD withdrawal of support for CMMI, and the threat of sequestration looming over the defense industrial base, but not competitiveness. Moderate improvement in encouraging innovation within the U.S. software industry may serve to boost competitiveness with innovation in the small, in evidence, while impacting security as mobile and bring your own device offer new challenges to cybersecurity. In summary, on the one hand, software practice continues to be a challenge, revealing itself most evidently as an enabler to the nation's cybersecurity threat. On the other hand, software houses much of the innovation that underlines the nation's global competitiveness. Terms of reference focuses on supply chain background, objective and benefit, criteria for success, and the session learning objectives. Supply chains in the wild are intrinsically risky, vulnerable to cybercrime and cloud computing risks, as well as organizational neglect and unmet needs. The practice of risk management using smart and trusted tactics is necessary because software-based supply chains are inherently insecure. The risks and uncertainties are prolific, and vulnerabilities abound. The combination of unmet needs, industry neglect, and austerity, coupled with the immature state of software, cybersecurity, and cloud computing infrastructure, yield a rich environment of uncertainty and risk. Supply chains are complex. Just as one thing leads to another, In supply chains, many things must lead to one thing, despite event threats and external factors. Supply chain cost and quality service level agreements may be threatened as Tier 2 and Tier 3 nodes populate the network with uncertain chain of custody and provenance. Unanticipated global and external threat events make their appearance, and cybersecurity threats insinuate the supply chain network through unprotected Tier 2 and Tier 3 nodes. Beyond that, the Chief Procurement Officer, CPO, serves as the principal single point of failure threatening resiliency. The objective of rolling out the Supply Chain Risk Management Assurance Framework is to advance the assurance of smart and trusted risk management principles and practices useful and essential for military, government, critical industries, and commercial industry. The benefit of the Supply Chain Risk Management Assurance Framework will be to elevate the expert application of risk management principles and practices in order to reduce uncertainty in the assurance of software-intensive supply chains through the use of smart and trusted tactics designed to deliver consequential outcomes in assuring supply chain trustworthiness, security, resilience, product integrity, coordination, control, and flexibility. The criteria for success of the Supply Chain Risk Management Assurance Framework lies in the rate of adoption by supply chain owners and operators, followed by their progressive advancement in supply chain risk management assurance maturity. 5 levels of maturity are envisioned, spanning management commitment, engineered flow control, process risk calculation, and global challenges strategies. Specifically, adopters of the Supply Chain Risk Management Assurance Framework will be better able to systematically pinpoint the factors and sources of risk involved in supply chain risk management and software-intensive projects, to identify concrete supply chain risk management objectives involved and consequential outcomes sought in meeting each of the goals associated with establishing and maintaining infrastructure, being trusted, being competitive, and being austere. To visualize the operations of the software and supply chain risk management assurance and achievable service level agreements through the use of assurance assertions based on goals and objectives, and appropriate indicators, measures, metrics, and analytics. To calculate supply chain assurance risks based on the factors evaluated for each goal. Account of factors might serve as the sources of problems in goal achievement, and account of factors that represent objectives that are in a failed state. For each goal, the calculated risk is the number of problems divided by factors evaluated expressed as a percent. To calculate supply chain risk management assurance rollout and maturity progress with military, government, and critical infrastructure and commercial industry peers, useful in boosting brand value. Framework foundation spans framework purpose, framework application, 3 levels of indirection, strategic goals and tactical objectives, and supply chain risk management factors. The purpose of the Supply Chain Risk Management Assurance Framework is not to prescribe or impose supply chain practice or methods. Instead, the purpose of the Supply Chain Risk Management Assurance Framework is to encourage, stimulate, and incentivize supply chain owners and operators to positively and proactively assure the identification, mitigation, transfer, or acceptance of the sources of risk, problems, and factors that may impede the achievement of supply chain goals and objectives. Software and supply chain risk management assurance is the application of risk management principles and practices to reduce uncertainty in the assurance of software-intensive supply chains through the use of software-based smart and trusted tactics designed to deliver consequential outcomes in assuring supply chain trustworthiness, security, resilience, product integrity, coordination, control, and flexibility. Goals associated with smart and trusted software and supply chain risk management include maintaining infrastructure, being trusted, being competitive, and being austere. An industrial strength software risk management practice is one that treats risk as uncertainty, carefully distinguishes risks from the sources of risk and problems, and doesn't use risk management as an off-ramp to avoid actually solving problems. Based on analysis conducted, factors evaluated, sources of problems identified, and problems representing objectives in a failed state, the software and supply chain assurance risk is assigned high risk, driven by the numerous infrastructure factors in a failed state, including austerity risk, software risk, internet risk, and cloud risk. In addition, trust and competitiveness are assigned moderate risk. Descriptive, not prescriptive. It is important to understand that the supply chain risk management assurance framework, by necessity, operates under three levels of indirection. First, it is a framework, a basic underlying structure. Second, it promises assurance, a positive declaration intended to inspire confidence. Third, it manages risk through the identification, elimination, mitigation, transfer, or acceptance of factors, sources of risk, and problems that may impede the achievement of supply chain goals and objectives. As a framework, the supply chain risk management assurance framework focuses on the infrastructure of management, engineering, process, technology, and skills needed to acquire, field, and operate trusted, competitive, and austere software-based supply chains with intelligence and confidence. As an assurance mechanism, the supply chain risk management assurance framework validates positive declarations intended to inspire confidence using assurance assertions and levels of confidence. As a risk mechanism, the supply chain risk management assurance framework seeks to prudently assign the disposition of risks associated with factors, sources of risk, and problems, and to calculate the risk associated with supply chain goals and objectives. Setting goals is the first step in managing risk. Goals are attributes to be assured. Goals associated with smart and trusted software and supply chain risk management assurance include maintaining infrastructure, being trusted, being competitive, and being austere. Objectives associated with goals are factors with consequential outcomes. For example, performance, product integrity, mission, resilience, innovation, flexibility, efficiency, control, leadership, coordination, and risk. The software and supply chain risk management assurance framework spans a wide range of goals, objectives, elements, issues, and factors associated with systems and software management, process and engineering methods, practices, technologies, tools, and skills underlying acquisition and operations. Primarily related to infrastructure, these supply chain risk management factors include supply chain risk management, assurance assertion management, capability maturity model integration, state of austerity, state of software, state of security, state of cloud security, NIST Cloud Computing Reference Architecture, NIST Cloud Service Level Agreements, NIST Cyber Framework. Primarily related to trust and austerity, these supply chain risk management factors include cyber tactics, software assurance, trusted chain of custody, counterfeit and tainted component detection, software product engineering, trustworthy software engineering, technical debt, software project management, earned value management, and fixed price contracting. Primarily related to competitiveness and austerity, these supply chain risk management factors include offshore outsourcing, cost return ratio, next generation software engineering, frequency of release, global software competitiveness, science, technology, engineering, mathematics, team innovation management. Risk management spans risk and uncertainty, setting goals, assurance, assertion, argument questions, and calculated risk. Risk is uncertainty and the prospect for loss or gain, depending on the outcome of an event. An industrial strength software risk management practice is one that treats risk as uncertainty, carefully distinguishes risks from the sources of risk and problems, and doesn't use risk management as an off-ramp to avoid actually solving problems. Since risk is uncertainty, the challenge is to calculate the uncertainty of a risk and accept only those risks whose joint probability of occurrence and prospect for loss or gain are prudent choices. These are considered calculated risks. Setting goals is the first step in managing risk. Goals are attributes to be assured. Goals associated with smart and trusted software and supply chain risk management assurance include maintaining infrastructure, being trusted, being competitive, and being austere. Objectives associated with goals are directed at consequential outcomes. Sources of risk are objective outcomes whose achievement is at risk and uncertain. Problems are objective outcomes that have failed. All within this context, the framework advocates and advances the use of assurance assertions that are composed based on goals and objectives and appropriate indicators, measures, metrics, and analytics. The assurance of an attribute or aspect is specified by an assurance assertion composed of a claim, arguments, and evidence chain. Assurance assertions themselves are subject to validation and verification. The assurance assertion chain is validated when the correspondence between a claim and its arguments is shown to be clear and convincing with respect to completeness and correctness. The argument evidence segment of the assurance claim is verified according to the correspondence between the evidence and the argument. Here, 4 levels of confidence for appraising evidence are identified as follows. The evidence in support of the argument is sufficient. The preponderance of the evidence supports the argument. The evidence in support of the argument is clear and convincing. The evidence in support of the argument is beyond the shadow of a doubt. Infrastructure is maintained by meeting the objectives associated with software and supply chain risk management framework, risk management, assertion management, austerity risk, software risk, internet risk, and cloud risk. Of these objectives, the following are problems, that is, they are failed objectives: austerity risk, software risk, internet risk, and cloud risk. As a consequence, acquiring and operating satisfactory supply chain infrastructure is high risk. Evidence-based assurance assertion assessment questions associated with assurance assertion management include: are sources of risk factors expressed as assertions with assessable arguments? Is the evidence in support of arguments assessed as insufficient, preponderance, clear and convincing, or beyond the shadow of a doubt? Are these assessments taken into account in calculating supply chain risk. Evidence-based assurance assertion assessment questions associated with cloud computing include: has the cloud vendor's reputation been assessed and found to be acceptable? Does the cloud vendor comply with the NIST Cloud Computing Reference Architecture? Does the cloud vendor accept a service level agreement to protect and safeguard proprietary data and information? Have the possibility and security risks of multi-tenancy been assessed and found to be acceptable? Trust is achieved by meeting the objectives associated with reputation, build security in, completeness, correctness, consistency, software product engineering, quality, technical depth, cybersecurity, cyber tactics, trustworthiness, security, resilience, chain of custody, counterfeit, high assurance, survivability, mission compliance. Of these objectives, the following are problems, that is, they are failed objectives. Build security in, technical depth, cybersecurity, security, resilience. As a consequence, acquiring and operating a trusted supply chain is moderate risk. Evidence-based assurance assertion assessment questions associated with software assurance include: are build security in practices followed? Are known security vulnerabilities understood, monitored, and avoided? Are known security weaknesses understood, monitored, and avoided? Evidence-based assurance assertion assessment questions associated with trusted chain of custody include: is the chain of custody identified? Is the accountability of permissible access maintained, updated, and reviewed? Is the chain of custody unbroken? Are access logs kept, maintained, and reviewed for evidence of tampering? Evidence-based assurance assertion assessment questions associated with counterfeit and tainted component detection include: does the organization have the capability to apply static analysis of source code? Does the organization have the capability to apply function extraction of object code? Does the organization have the capability to apply rigorous software inspections process on the source code? Competitiveness is achieved by meeting the objectives associated with control the workforce, STEM, control customers, control competition, control events, sustainability of wages. Of these objectives, the following are problems, that is, they are failed objectives: STEM and control event threats. As a consequence, acquiring and operating a competitive supply chain is moderate risk. Evidence-based assurance assertion assessment questions associated with STEM include: are STEM workforce requirements known and understood? Are outstanding personnel requisitions periodically reviewed by senior management? Are alternate sourcing measures, including offshore outsourcing, identified, understood, monitored, and activated as necessary? Evidence-based assurance assertion assessment questions associated with offshore outsourcing include: is a cost-return ratio calculated during planning and recalculated periodically? Are control points established for the global enterprise? Are control points established for the outsourced vendor? Does a trusted pipe architecture feature an in-country control point connected by high-speed secure line to an out-country control point with defined capabilities and protocols? Do intelligent middlemen possess necessary hard and soft skills? Are outsourcing risks understood, monitored, and controlled? Evidence-based assurance assertion assessment questions associated with global software competitiveness include: are suppliers understood, monitored, and controlled? Are customers understood, monitored, and controlled? Are competitors understood, monitored, and controlled? Are threat events understood, monitored, and controlled? Austerity is achieved by meeting the objectives associated with economics, next generation software engineering, fixed price contracting, software project management, earned value, offshore outsourcing, capability maturity model integration, and cloud computing. Of these objectives, the following is a problem. That is, it is a failed objective: fixed price. As a consequence, acquiring and operating an austere supply chain is low risk. Evidence-based assurance assertion assessment questions associated with fixed price contracting include: is the organization committed to fixed price contracting? Is the organization committed to systems engineering and software engineering collaboration? Are software development plans structured as incremental development with well-specified design levels and cost accounts? Is there strict accountability of cost accounts based on a work breakdown structure? Are fixed price doctrine tenets for a project management, process management, and product engineering adhered to in practice? Evidence-based assurance assertion assessment questions associated with next generation software engineering include: is user domain awareness maintained? Are systems and software produced using a shortened development lifecycle? Are trustworthy applications composed from parts? Are resilient systems of systems composed from systems? Risk is uncertainty and the prospect for loss or gain depending on the outcome of an event. An industrial strength software risk management practice is one that treats risk as uncertainty, carefully distinguishes risks from the sources of risk and problems, and doesn't use risk management as an off-ramp to avoid actually solving problems. Since risk is uncertainty, the challenge is to calculate the uncertainty of a risk and accept only those risks whose joint probability of occurrence and prospect for loss or gain are prudent choices. These are considered calculated risks. Setting goals is the first step in managing risk. Goals are attributes to be assured. Goals associated with smart and trusted software and supply chain risk management assurance include maintaining infrastructure, being trusted, being competitive, and being austere. Corporate success strategies need to be composed of essential goals and consequential objectives. Objectives associated with goals are directed at consequential outcomes. Sources of risk are objective outcomes whose achievement is at risk and uncertain. Problems are objective outcomes that have failed. For each goal, the calculated risk is the number of problems divided by factors evaluated, expressed as a percent. Overall supply chain assurance risk is determined by rule. Rule 1. If infrastructure or trust or competitiveness or austerity equals high risk, then supply chain is assigned high risk. Rule 2. If infrastructure or trust or competitiveness or austerity equals moderate risk and not high risk, then supply chain is assigned moderate risk. Rule 3. If infrastructure and trust and competitiveness and security equals low risk, then supply chain is assigned low risk. Where the calculated risk of any goal is 50% or over, it is assigned high risk, driving the overall supply chain risk assignment to high risk. Where the calculated risk of any goal between 25 and 50%, it is assigned moderate risk, driving the supply chain risk assignment to moderate risk as long as there are no high-risk goals, Where the calculated risk of any goal is under 25%, it is assigned low risk, driving the supply chain assignment to low risk as long as there are no moderate risk or high risk goals. Based on analysis conducted, factors evaluated, sources of problems identified, and problems representing objectives in a failed state, the software and supply chain assurance risk is assigned high risk, driven by the numerous infrastructure factors in a failed state, including austerity risk, software risk, internet risk, and cloud risk. In addition, trust and competitiveness are assigned moderate risk. Supply chain assurance risk is calculated based on the factors evaluated for each goal. A count of factors that might serve as sources of problems in goal achievement, and a count of factors that represent objectives that are in a failed state. Specific findings include maintaining infrastructure is considered high risk due to the failed or immature state of austerity, software, internet, and cloud. Being trusted is considered moderate risk due to the failed or immature state of build security and technical debt, cybersecurity, security, and resilience. Being competitive is considered moderate risk due to the failed or immature state of STEM and control of event threats. Being austere is considered low risk due to the failed or immature state of fixed price contracting. Recommendations include supply chain success depends on maintaining an infrastructure of austerity, software, internet, and cloud. Very high priority attention and investment in management and engineering are recommended. Supply chain success depends on being trusted. High priority attention and investment in management, engineering, and process in the factors of build security and technical debt, cybersecurity, security, and resilience are recommended. Supply chain success depends on being competitive. Priority attention and investment in STEM and control of event threats are recommended. Supply chain success depends on being austere. Attention and investment in management, engineering, and process in the factor of fixed price contracting is recommended. Supply chain advancement revolves around rollout maturity levels, global challenge strategies, and public policy incentives. A target organization adopting the supply chain risk management assurance framework rollout is progressively locked in as it advances through the 5 levels of maturity rollout, including level 1, lack of commitment, level 2, management commitment, vision and goals, level 3, engineered flow control, strategic objectives with consequential outcomes, factors that serve as sources of risk or problems. Level 4, process risk calculation, evidence-based assertion argument-driven assurance assessment of sources of risk and problems. Level 5, global challenge strategies, standards-based certification versus tightly controlled indigenous innovation. Supply chain maturity seeks some of the same consequential outcomes as traditional organizational maturity, such as more efficiency, more predictability, less risk, and less chaos. Yet, supply chains have less ability to exert control, leadership, and coordination over its nodes. Not only that, supply chains need to be formed and reformed based on performance of suppliers, the arrival of new suppliers, and threat events, whether local or global. All this means that supply chain maturity cannot be locked in the traditional way expected of those used to pursuing organizational maturity. In fact, these flexible supply chain course changes reset supply chain maturity as new priorities and new nodes replace old ones in the interest of resiliency and dull the edge of efficiency so highly valued. The global challenge for supply chain risk management assurance is trust. What are the boundaries and limits of supply chain risk management assurance trust? Number one, to what extent can standards-based certification be relied upon to deliver trust through transparency? This is necessary and sufficient for industry to reach the global boundary of trust. China's strategy of indigenous innovation can be relied upon to deliver trust through regulated internal corporate controls. This is necessary and sufficient for government and military to reach the country boundary of trust. Is the outer boundary of trust the enterprise, the country, or the globe? For government, for military, for critical infrastructure, for commercial industry? Within what boundaries is the trusted chain of custody unbroken? To what level of confidence is the chain of custody assertion backed up by evidence-based assurance assessment? The evidence in support of the argument is insufficient, therefore not trusted. The preponderance of the evidence supports the argument, perhaps sufficient for trusted for government industry. The evidence in support of the argument is clear and convincing, perhaps sufficient for trusted for government and critical infrastructure. The evidence in support of the argument is beyond the shadow of a doubt, perhaps necessary for trusted for military. Achieving maturity in supply chain risk management assurance is an imperative with national economic and security implications. Public policy incentives are needed to encourage and further lock in adoption of the maturity model. The right mix of public policy accords as much self-determination as possible and invokes as little regulation as necessary. Public policy incentives revolve around the following public policy measures. Number one, market-driven tactics are centered around industry standards, activities, voluntary compliance, and public-private collaboration for information sharing. Number two, self-help remedies are government-sanctioned, low-cost actions whose practitioners are usually accorded the benefit of a doubt. For example, consider the electronic repossession of a vehicle by satellite signal shutdown after it violates terms of agreement for speed or location. Number three, targeted investment and funding can be used to stimulate research in critical areas. Number four, insurance mechanisms can be used to reduce business resistance where unknown or low probability of occurrence of events are involved. Import tariffs on offshore outsourcing have been considered by some. Tariffs would be used to produce revenue to fund domestic software research and education. In addition, tariffs would be structured to even the playing field for the domestic software workforce. Number six, tax policy, such as research and engineering tax credit, can be powerful, but it is difficult to get all stakeholders on the same page. These include the creators of technology, the users of technology, the legislative community, the legal profession, and the judicial arm. Number seven, guiding regulations are useful as mid-course corrections to achieve policy goals and as clarifications where they are needed, such as export controls and antitrust litigation. Number eight, targeted legislation appears attractive. However, congressional leaders often lack a sufficient understanding of technology and software issues. Conclusion is made up of final comments, questions and answers, and wrap-up. With austerity as the context and contemporary software and security as unmet challenges, the Software and Supply Chain Risk Management Assurance Framework focuses on the infrastructure of management, engineering, process, technology, and skills needed to acquire, field, and operate trusted, competitive, and austere software-based supply chains with intelligence and confidence. The intended benefit statement for the software and supply chain risk management assurance framework is to deliver smart and trusted supply chain acquisition and operation. The factors populating the framework begin with a heavy-duty focus on trust, beginning with trust in industrial frameworks, industry state of the practice, and the underlying skills and body of knowledge. From there, other factors utilize smart validation mechanisms with rigorous confidence levels spanning management, engineering, and process operations. Finally, data-driven decision-making is fueled by a range of metrics for assurance, compliance, non-compliance, product engineering, management, and process. This comprehensive and realistic framing of solutions and challenges in the software and supply chain risk management assurance space will deliver intelligent and confident outcomes tied to the goals of the initiative, including maintaining infrastructure, being trusted, being competitive, and being austere. Maintaining infrastructure is considered high risk. Being trusted is considered moderate risk. Being competitive is considered moderate risk, and being austere is considered low risk. Based on analysis conducted, factors evaluated, sources of problems identified, and problems representing objectives in a failed state, the software and supply chain assurance risk is assigned high risk due to the failed or immature state of austerity, software, internet, cloud, build security in, technical debt, cybersecurity, security, resilience, STEM, control of event threats, and fixed price contracting factors. Here is my contact information. I would be happy to receive questions and have discussions with people on this important subject.